Hello students, welcome to this online paper discussion session. Today we are going to discuss this paper 11 PM QB1. PM represents properties of matter. Here in this chapter we have discussed few important properties of matter like viscosity, surface tension and elasticity. So this paper consists of questions in this chapter. Like the last video, you can also find the paper in the discussion box below, and in the discussion box I have given you the time profile of each and every question. So if you want to save time and you want to see a solution of particular question, you can directly jump to that timeline and you can see the solution of that question. So let's see what do we have in this question paper. The first question, it says a solid sphere of radius r made up of a material of bulk modulus k surrounded by a liquid in a cylinder. Massless piston of area A floats when the mass capital M is placed on the piston. Then what is the fractional change in radius of the sphere? Fractional change means delta r divided by r. So let us draw a sphere first. Let us assume this is to be a sphere. It is inside a cylinder and there is a piston. Let us assume this to be piston. It is kept in liquid, and so when we have placed a mass m here, then the question is asking what is the radius, the fractional change of the radius. The material bulk modulus of this sphere is given as k. So how do we solve this question? You can see that whenever we have placed that mass on the piston, the pressure on this liquid, the pressure inside the liquid has increased by this amount delta P, which is given as mg divided by A. So if the pressure delta P is this one, from the definition of bulk modulus, I can find that delta P divided by delta V by V, that is the bulk modulus with a negative sign. Because of delta V will decrease, V will decrease, volume will decrease as pressure increases. From there I can say that the bulk modulus is given K into delta V divided by V is equal to delta P, and from there we can say that delta V, I have only taken the modulus of it, delta V is equal to delta P into V by K. So delta V by V, delta V by V is delta P by K, which is nothing but mg divided by A into K. That is given. That is known to us. Now it is simple. We have to relate V and R. We know that V is equal to of a sphere 4/3 pi r cube. So what is delta V? It is nothing but dV, because the change is very small. 4/3 pi into 3r square into dr. So what is dV by V? It is divided by 4/3 pi r cube. You can see that dV by V is nothing but 3 into dr by r. So from this equation I can say that dr by r is equal to 1/3 of dV by V, which is nothing but mg by ak. So the option B will be your correct choice. Move to the second question. It says a steel wire of negligible mass, length 12, cross section area A, Young's modulus Y is held between two rigid walls. A small body of mass m is suspended from the middle point. What is the vertical descent of the wire? So let us draw the situation. This is the still wire. So when I suspended the mass, the wire will bend like this. So its middle section has come down by, suppose, a distance y. We need to find the value of y, and let us assume this angle is theta. It is very obvious that this theta is very small. Also the y is also very small. The value of y is also very small. So this length is L, this length is L. What is the value of this length? That we need to first find out. So can I say that this length is nothing but root over of L square plus y square. What is delta L? That means the elongation of this part. Can I say delta L is equal to L square plus y square whole power half minus of L. That is L square if I take common outside, 1 plus y square by L square to the power half minus L. As you can see that y is much less than L. So that part y square by L square is very small compared to 1. I can binomially expand this thing. So it is 1 plus y square by 2L square minus L. So it is L minus y square by 2L minus of L. So it becomes y square by 2L. So that is the delta L. So if it is delta L, then it has a tension T. This side has also the same tension T. So the T cos theta part will get cancelled out, and the vertical part is 2T sin theta. 2T sin theta, that is equal to mg. That is my equation. Now again, theta is very small, so I can approximate sin theta to be theta. So 2T theta is equal to mg. Now, what is the tension T? If I say that T by area of cross section is equal to y, Young's modulus, into delta L by L. So T is equal to ay into delta L by L. Delta L by L. Now delta L by L is y square by 2L square. So it is A into Young's modulus into y square by 2L square. So what is 2T here? I can say 2T is equal to A y square divided by L square. Now again, theta is equal to tan theta. For approximation, we can always use sin theta is equal to theta is equal to tan theta when theta is small. It is also called small angle approximation. And tan theta from this triangle is nothing but y by L. So that also becomes y by L is equal to mg. From there, if you try to find the value of y, it is y cube. So it is mg by ay into L cube. So if you solve it, you will eventually find the option A correct. Come to this question. It says length of an elastic cord is L1 when the tension is T1 and L2 when the tension is T2. What is the natural length of the wire? So it is a very simple question. We can say that any wire can be assumed to be a spring because of its elastic property. So if I apply a force F on it, and if I apply the same force F on it, then the elongation, if it is delta L, then we can say that F is proportional to delta L. So in the first case, it is given that T1 is equal to some constant into delta L. Now what is delta L? Delta L is the elongation. So if the natural length is L0 and the length after elongation is L1, so the elongated part is L1 minus L0, and the second case T2 is equal to K into L2 minus L0. So if I try to solve it, I will first divide T1 by T2, and that will become L1 minus L0 by L2 minus L0. Cross multiply it, T1 L2 minus T1 L0 is equal to T2 L1 minus T2 L0. Take L0 in one side, you will find T2 minus T1 into L0 equal to T2 L1 minus T1 L2. So L0 is equal to T2 L1 minus T1 L2 divided by T2 minus T1. So I think option C is correct. If I multiply numerator denominator by minus 1, then I will find this 1. So option C will be the correct choice. Come to this question. Consider a small water drop in air. If T is the surface tension, what is the force due to surface tension acting on the smaller section ABC? The section ABC is shaded given in your picture. So if I redraw that part ABC, you can see that force of surface tensions are acting like this. So what that surface tension is actually, this force is actually balancing. This force is actually balancing the force due to this excess pressure, delta P into area. Which area I will take? Always we should take the projected area, this part. So this part area is easy to find from this triangle. The radius is r sine theta. The area is equal to pi r sine theta whole square. Pi r sine theta whole square. So the answer should be delta P into area, that is the force of surface tension. Now we know that excess pressure in water drop is 2T by R, and area is pi r square sine square theta. R will get cancelled out and you will get your answer. Option C will be the correct choice. Let's solve this one. Three concentric wires of radii ABC contains two different liquid films of surface tension T1, T2. As shown in figure, the outermost and the innermost wires are fixed. What is the tension in the middle wire? Now it is asking for the tension in the wire. So I cannot find the tension in the wire if I draw the free body diagram of the complete wire. So I should draw this part or section of the middle wire. So this is the middle wire and I will take a small section on the middle wire. So let us assume the section is like this. It is so small that I can consider this to be a straight line. And what is the angle that this arc is making at the center? Let us assume it to be delta theta or d theta. So if I divide it in middle, so it is d theta by 2, it is d theta by 2. And the tension are acting always tangential to the wire. These are the tensions. So if I take components of the tension, you can see that the horizontal components will get cancelled out. Only the vertical components will remain and they will be added. The vertical components, if it is d theta by 2, this is also d theta by 2. So this is d theta by 2. So this remains the sine component t sine d theta by 2, and it is also t sine d theta by 2. And what is the outside force? That you need to first understand. This is the part, this is a small part. So what is the tension, surface tension force on this part? Surface tension on this side is equal to 2 T2 into the length, which is r d theta. Why? Because surface tension is equal to S into L, or T into L. What is the length of this part? The length of this part is definitely r d theta. And what is it? Is a straight line that I have assumed because it is very small part. And as a film, it is a soft film, so there are two free surfaces, two air water interface. One is above the plane, one is below the plane, right? And similarly, there will be a surface tension force due to this red soft film that is shown in the outer part of the wire. So that is equal to T1 into r d theta, and that is also the 2 times because of the two surfaces. So what is the net force that is acting upward, that is acting outside of this where? That is T1 minus T2, T1 minus T2 into 2r d theta. Now I can balance this tension force with this, and again we will use the small theta approximation. So it is T sine d theta by 2, as theta is small, d theta is small, we can say it is only d theta by 2. So 2t sine d theta by 2 is d theta by 2 is equal to 2r into T1 minus T2 into d theta. So d theta will get cancelled out. Here 2 will get cancelled out. So T is equal to T1 minus T2 2 times. And what is the radius? That radius I will take. That radius is B. So that will give you option B correct. Come to this problem. AB is a massless, frictionless glass rod which can slide on U frame XX prime. So this is the rod which can slide on this frame. It is tilted like this. A water film is formed in a U-shaped frame. The rod is held in equilibrium by a spring of K. Surface tension is T and length is L. So it is 90-degree also shown. If I draw the free body diagram of this part, and the spring is elongated by delta x, then spring force is K delta x, and the surface tension force in this direction is equal to 2 into T into L. Right? So this is a very simple question. So they will only balance each other. Right? There is no friction anywhere. So they are going to balance each other. So K delta x equal to 2TL. So delta x equal to 2TL by K. That should be your correct answer. Very simple question. Question 7. It says a liquid is contained in vertical tube of semicircular cross section. The contact angle is 0. The force of surface tension in the flat part to the curved part. Now the surface tension will only act on air water interface, that is only on the upper surface of the liquid. So we will only consider the upper surface of the liquid. Here it is the container. So you can see that the surface tension, the liquid is kept here, liquid is kept here. So this part, this is the flat part, as the contact angle is 0 degree. So this flat part, the force of surface tension is perpendicular to this line, and it is S into L. L is 2R for this part. And for this curved part also, the angle is 0 degree, the contact angle, and the force of surface tension are acting like this on all these lines. So this line, the length is equal to pi into r. So the surface tension force is equal to S into pi r. So the ratio is equal to 2 is to pi. That should be your correct answer. It is also an easy question. Now it says a glass capillary tube of radius r is inserted inside water of density rho, so that some of the water rises in it. Another liquid of density rho is poured until the surface of meniscus inside the tube comes to the same horizontal level. If the surface tension of water is S, contact angle is 0 degree, then what is the height? H. Okay, so we can say that this outside pressure is atmospheric pressure P naught. So as it is inside, bulging inside, so if this pressure is P naught, the pressure just inside this meniscus at this point, pressure must be less than P naught. So it is P naught minus, as it is only one interface, so it is 2s divided by r. I have taken the radius of meniscus also to be r because the contact angle is 0 degree. And what will be the pressure at this point? Then pressure at this point will be P naught minus 2s by r plus rho into g into h. The height is h. So this is the pressure at this point. Now let us come to this point by this surface. So this surface pressure is P naught and pressure at this point is P naught plus sigma g h. As they are in the same liquid and same horizontal level, so these two pressures must be equal. So I can say P naught minus 2s by r plus rho gh, it should be equal to P naught plus sigma gh. From there, P naught gets cancelled out. The value of h you will get is 2s divided by r into g into rho minus sigma. 2s by rg into rho minus sigma. Option 1 will be your correct choice. Let's discuss this one. A heavy block of mass 150 kg hangs with the help of three vertical wires of equal length, equal cross section area. Wire is attached to the midpoint of the block. Take y2 equal to 2y1. For this arrangement, always remain equal horizontal. Find out the correct statements. Okay, so according to this question, it is a block and three wires are connected to this block like this. They are having the same length and same cross section area, but the Young's modulus, if it is y1, it is 2y1 and it is y3 given, right? Now as it always remains in horizontal and these distances are same mentioned in your figure question, so the torque about the center of mass of this tension and this tension should always be the same. So as the distances are same and the tensions should be same because the net torque should be 0, otherwise it will rotate. So if the tension in this wire is T1, tension is this wire will also be T1. As the tensions are same and the area of cross section are same as well as the length are same, then I have to say that Young's modulus are also same, right? Why I can say that? Because this T divided by A is equal to Y into delta L by L, right? So if it has to always remain in in horizontal position, then the elongation of this part, the elongation of this part and the elongation of this part, they should be the same. So delta L will be the same, L is same, A is given the same. So if tension is also same, then only it will not produce any torque. So if tension is also same in both the cases, both the wires, then Young's modulus should be the same in this first and the third one. So y1 equal to y3. Option A should be a correct choice. Tension in 1 and 3 would be always equal. That is also correct choice. Otherwise there will be a torque produced. Tension in 1 and 3 would be always different. That is not correct answer. Tension in 2. So I need to find out the tension in this word 2. T2. One equation I can readily write the force equation, that T1 2T1 plus T2 is equal to 150 G. Another equation I can write down from this expression, as delta L has to remain same for all these three wires. So for the third wire, first and third wire, I can say T1 by A is equal to Y1 into delta L by L, and for the second one, I can say T2 by A is equal to 2Y1 into same delta L by L, because it is horizontal, so delta L will be the same for all of them. So from these two expressions, this one and this one, I can say T2 is equal to nothing but 2T1. T2 is equal to 2T1. So if I replace 2T1 by T2, and again T2 is equal to 150G, then the value of T2 comes 75G. That is also the correct choice. So A, B, D will be your correct options. Okay, let's solve this question number 10. Two wires A and B have the same cross section and are made of same material, but of length A is twice that of B. So length of A is say 2L and the length of B is L. Same cross section area, made of same material, A and Y are same. So for a given load, that means I am applying the same force to both of them. So this equation should be F by A is stress equal to Y into delta L A divided by 2L, and for here F by A is equal to stress equal to Y into delta L of B divided by L. Extension of A will be twice that of B. So delta L A will be 2 times delta L B, that is the correct option. Strain in A will be half in B. Strain means this part. This part. Now this part is a strain. Both of them it is F by AY. So both of them will be equal. A and D will be the correct options. It is also a very simple question. Question number 11 says a composite rod consists of steel rod of length 25 cm, area 2A, copper rod of length 50 cm, area A. Suppose this is copper rod of area A and length L, length 2L, and it is a steel rod of cross section area 2A and the length L, because steel rod is 25 cm, copper rod is 50 cm. The composite rod is subjected to an axial load F. Okay, so the rods are copper and steel, they are made like this. This is say steel and it is copper, like this. Copper and steel. Steel 2A, copper radial cross section area A. Okay, so they are like this, and I have applied a force F here. Young's modulus of steel and copper 2:1. So copper if it is Y, steel it is 2Y. What is the extension produced in copper rod? The extension produced in copper rod will be more extension. Okay, so let us try to draw the free body diagram of steel and copper separately. For steel, the force is F. For copper, also the force is F. For steel, I can write F by 2A, is equal to delta L of steel by steel L into Y of steel is to Y, and for copper rod we can write F by A is equal to Y into delta L of copper divided by 12. Okay, so what is the extension? Delta L of steel, that is equal to F into L by 4AY, and delta L of copper is equal to F into 2L by AY, right? So you can see that the extension of copper is more. Extension of copper and steel are in the ratio of 2 by 1 by 4. Yes, it is 8 is to 1. It is also correct option. Stress applied to copper rod will be more. Stress. Stress is F by A. Copper stress is F by A. Steel stress is F by 2A. So yes, the stress in copper is more. F by A is more. No extension will be produced in the steel rod. No, that is wrong, because there will be some extension in the steel rod. So ABC will be your correct options. Let us try to solve this question. It is a good question. It says a spherical ball of radius r and mass m, initially at rest, placed at origin inside a liquid of coefficient viscosity eta. The ball is projected with velocity v naught I cap. Choose the correct options. V naught is mg by 6 pi eta r, gravitational acceleration g, neglect buoyancy. So if I try to draw the free body diagram of the ball at any instant, suppose the ball is moving with certain velocity v at any instant. This is velocity v. So its force due to this viscosity, which is given by Stokes law, is just opposite to its velocity, and that will be 6 pi eta r into v vector. Let us assume it to be kv. The force will be minus v vector. The force will be minus kv vector. Along with it, there is an mg force always acting downward. So if I try to write where k here in this equation, k is equal to 6 pi eta r. So if I write down the force equation of that ball at any instant, the force equal to minus of mg j cap and minus kv vector. So if I assume the velocity at any instant, v vector is equal to vx I cap plus vy j cap, then what will be the force is equal to minus mg j cap minus kvx I cap minus kvy j cap. What I will do with that force, I will write this force equal to m into dv by dy. dv by dy means there are two forces, d in along x and along y. So along x, can I write m dvx by dt? So that is equal to, along x direction it is minus kvx, and along y direction can I write the force is m into dvy dt, that is equal to force along y direction, that is minus of mg minus kvy. Now I have got two equations, one is for x, one is for y. If I integrate those equations, I will find the value of vx and vy with a function of time. For example, if I integrate this value of vx, then it is dvx by vx, that is equal to minus k by m dt. So if I integrate this function at t equal to 0, the value of vx is v naught, at time t is vx. So if I integrate this, it is ln of vx by v naught is equal to minus k by m into t. From there, we can find the value of vx is equal to v naught into e power minus k by m into t. So that is the value of vx that we have got. Similarly, we can integrate this equation to find the equation of vy. So if I integrate it, it will come dvy divided by m in this side. So it will be g plus k by mvy, that is equal to minus dt. If I integrate it, here at t equal to 0, the velocity at y is 0. So after some time it is vy. So what you will find the equation, I'm trying directly writing this equation, you can solve it by yourself. Vy, you will find it is mg by k into e power minus k by mt minus 1. Again, mg by k is equal to v naught. From this equation, from here you can say that. So that is equal to v naught into 1 e power minus k by mt minus 1. Now we have got the equation of vx and vy. So if I know the equation of vx and vy, I can find the answers. The first option is x component of the velocity will half at t equal to v naught by g ln 2. That directly comes from this equation. X component half means vx is equal to v naught by 2, that is equal to v naught into e power minus k by m into t. So that comes to be ln 2 is equal to k by m into t, and k by m from this equation, k by m is equal to v naught by g. So that is v naught by g into t. So the value of t is equal to g by k by m is g by v naught. K by m is g by v naught. So the value of t will be v naught by g ln 2, that is the correct option. By the time x component will be half, y component will also be half of maximum value. Y component will be half of the maximum value. Maximum value of y component is v naught, because at t equal to infinite, v naught it will be 0. So the maximum value of vy is equal to minus v naught. If the x component is half, when e power minus k by m t is equal to half, so that is half minus 1 is equal to minus half. So the velocity will be minus v naught by 2. So that is also the maximum, half of the maximum value. Velocity of the ball after a long time, this will be 0. Vx will be 0 because t tends to infinity, so this becomes 0. But after a long time, vy will be minus v naught. So after a long time, the velocity will be in negative direction, negative y direction, and terminal velocity after a long time will be v naught, which will be in negative y direction. So ABCD, all the options are correct in this question. Let's find solution of this question. A soft solution is formed on a rectangular wireframe where one side is free to move. Initially, the movable side is held at rest and the elastic closed thread is kept on the surface of the solution. So it is a rectangular wireframe. This side is movable. Initially, it is kept at rest. And in the soft solution, I have kept a elastic thread. When the film inside the thread is pricked, then definitely it will become circular because the surface tension forces are acting radially outward. So it will become circular. So option A is correct choice. When the film inside the thread is pricked, there is no change. This will not be the correct option. After pricking inside the film, when we slide the movable rod, okay, so after it is pricked, this becomes circular and we are sliding this rod. It says whether the area under the thread will increase or remain same. Definitely it will remain the same because the force remains same. This surface tension force will not change. The area will change, and for that we are doing some work. So that area will not change. So this option D will be a correct option. That is a pretty good question. So that is a pretty straightforward question. A and D will be your correct options. Question number 14. When a capillary tube is dipped in a liquid, the liquid rises to a height h. The free liquid surface Inside the tube is hemispherical in shape. That means the contact angle is 0. So it was dipped initially in liquid, contact angle was 0, it was like this. It says that when the tube is now pushed down, so that height of the tube is less than h. So if the tube is pushed down, the height of the tube is less than h. Now what will happen? Now it is a question of insufficient length of the tube. If the length of the tube is insufficient, definitely the water will not come out, but the radius of curvature will increase. So liquid will come out slowly, will not be the correct option. Come out of the on a small fountain, not be the correct option. Option C, the free liquid surface inside the tube will not be hemispherical. Yes, because its radius of curvature will now increase. The liquid will fill the tube but not come out of the upper end. C and D will be the correct choices. Question number 15. A body of mass 10 kg connected to a wire of length 0.3 meter. L is 0.3 meter. Mass is given as 10 kg. And cross section area is 10 power minus 6. Breaking strength is 4.8 10 power 7. To maximum angular velocity with which it can be rotated. So if it is rotated in a circle, this length is L, this is M. So its tension is m omega square r, m omega square L. So this tension divided by area is stress. So m omega square L divided by area, that is the stress, and the maximum stress possible is the breaking stress given. It is 4.8 into 10 power 7. So what is the value of omega square? I can find it 4.8 10 power 7 into area 10 power minus 6. Divide it by m into L 0.3. If you solve, we will find omega to be 4 radian per second. That will be the answer of that question. Come to this one. A uniform elastic plank moves with a constant force F naught 84 Newton distributed uniformly over the end face of the plank. The area of the end face is 10 centimeters square. Young's modulus is given, and if the strain produced is x 10 power minus 7, the value of x. So let us first draw this plank. It is the plank, and it is given that area is given, the force F is applied, so it is accelerated, it is not at rest. Acceleration is equal to F divided by mass. So if I take a small section at a distance x, then the elongation will be different at different cross sections. Why? Because the tension at different part will be the different. If I draw the free body diagram of this part x only, then tension of this portion T is equal to mass into acceleration. The same acceleration it will also follow. So the mass is equal to total mass divided by length into x, into acceleration is F by m. So you can see that the tension is a function of x. Fx by L is the tension. So what is the stress? Stress is Fx by A into L is equal to y into Young's modulus into delta L. Now I am looking about this part only. I am looking about this part dx. So the elongation of this part dx, let us assume it to be dl, and the actual length of this part is dx. So that will be the equation from where I will find the value of total elongation. So total elongation, I will find dl is equal to F by A y into L into x dx. If I integrate it, I will find the total elongation from 0 to delta L. Total elongation is 0 to x, 0 to L. So that is equal to F by AY into, that is L squared by 2, L by 2AY. FL by 2AY is the total elongation. Now it is asking for the strain. Strain is equal to delta L by L. So strain is equal to F by 2AY. So strain is equal to F by 2AY. The value of F is 84 Newton. Okay, L is not there. F by 2ay, 2 into area is given 10 power 10 centimeters square. So 1 centimeter square 10 power minus 4, right? And Young's modulus is 2.1 into 10 power 11. Let us try to solve it. It is 42, and it is 10 21 21 42 means 2142 means 2. So it is 2 into 10 power minus 7. 2 into 10 power minus 7. The value of x should be 2. Let's come to this question. Surface tension and vapor pressure of a liquid at 30 degrees Celsius is 17.28. So surface tension is given 17.28 into 10 power minus 2, and vapor pressure is given 8.33 into 10 power 3. What is vapor pressure? At vapor pressure, the liquid pressure is vapor pressure, then liquid will evaporate, right? So if this is a liquid drop, if this is a liquid drop, then the excess pressure of it, excess pressure means the pressure that is excess of the atmospheric pressure. If it is P naught, it is P naught plus the liquid is 2T by R. So the excess pressure, if the excess pressure is greater than vapor pressure, then the liquid will evaporate. So excess pressure is 2T by R. If it is greater than P vapor, then it will evaporate. So for this question, 2T by R should be less than PV. So R should be greater than R should be greater than 2T by PV, right? So radius of the smallest liquid droplet. So minimum radius I have to find. If you find 2T, it is 2 into 17.28 into 10 power minus 2 divided by PV 8.33 into 10 power 3. So it is very simple calculation. You will find it is in order of 10 power minus 5 something. It is given in your question 4.85. So the value of x is 5 in this question. It is the last question. It says a ring of radius are made of where of density rho is rotated about stationary vertical axis passing through the center perpendicular to the plane. If the breaking stress is sigma, then what is the angular velocity which the ring breaks? Okay, if it is rotating with omega, then if it is a ring, it is rotating with omega, then I will draw the free body diagram of a very small portion, this one. So it can be assumed to be a straight part which makes an angle d theta at the center, where this equal part is r d theta by 2. The tensions are acting directly tangentially, so this part are tension and this angle at d theta by 2. So the vertical component of the tensions are t sine d theta by 2. They only remain there because t cos d theta by 2 will cancel out. The horizontal parts will get cancelled out. So what these parts are actually balancing? These parts are balancing the centrifugal force. If I sit on the rotating frame, then there is a centrifugal force which is the mass into omega square into r. And now what is the mass of this part? If the cross section area of this wire is a and the density is rho, then mass is equal to rho into a into length is r d theta, that is mass into omega square into r. So this force is balanced by this 2t sine d theta by 2, as I can say that d theta is very small. So sine d theta by 2 is nothing but d theta by 2. So net vertical force is 2t d theta by 2. That is balanced by rho a r square omega square d theta. D theta gets cancelled out. I can find the value of tension is rho a omega square r square. So the stress stress is tension by area, because I have to divide it tension with this area, that is A. The T by A is nothing but rho omega square r square. That is given as when it breaks, it reaches the breaking stress. So omega r is equal to under root sigma by rho. R is equal to 1, sigma by rho is 4. So the value of omega is 2 radian per second. That should be your answer. Thank you for watching this video. If you like this video, definitely hit the like button, share this with your friend. You will only be able to see the video when you have the link, because it is not a public video. So if you want to share this with your friend, then share the link. Thank you.